Section 3 is starting to look at some of the unique segments and relationships that happen in triangles. And so in this first section, we're going to be talking about a couple of these segments. So in altitude, you may be more familiar with an altitude being called a height. So depending on your book and your instruction, sometimes those are called a height. Now this is a unique segment with certain properties. Okay, it is a segment from one vertex perpendicular to the side opposite. It may be inside, outside, or on the triangle. And we'll look at some of those examples. So in this case, from this vertex perpendicular, this one is inside. Okay. Key is you know nothing here. You know nothing about the angles. And you know nothing here. You know nothing about if it's bisected or the lengths. An altitude, if you're given an altitude, the only thing you know is that it is perpendicular. That is it. None of the rest of it is a given by this definition. In this next case, you can see from this vertex perpendicular actually takes us outside the triangle. That's what the dashed line means. Here, we actually have all three drawn in. From this vertex, perpendicular happens to be on. From this vertex, perpendicular happens to be on. And then we have the one that is inside. So every triangle has three unique perpendicular altitudes. Now, another term we can use is a median. And this is a segment from one vertex to the midpoint of the opposite side. Now that's the key, is that it goes to the midpoint. So what I do know, vertex to the midpoint is right here. So I know equal segments. However, you know nothing about the angle. You don't know that it's bisected, you don't know that it's 1/3, you know nothing about that relationship. So you can't overgeneralize. You have to just go on what's given. So if we look at some examples, given AE is 9 and BE is a median, little piece of given that didn't show up in the notes here. So if this is a median, that means this piece and this piece are equal, just by definition of median. So if A to E is 9, all of that is my given. And I want to find EC. Well, that's easy. They're the same, the notation. That's 9. And I want to find AC. Well, by parts to whole, AC is 18. So EC is 9 and AC is 18. And if you mark your picture, that becomes a very simple problem. So let's look at another example. Find SC. So we're after this. And again, given SB is a median, as it says in your notes. Can't assume it, but I'm telling you. So that means that. Now, if SA is 6, SC is 6. It doesn't ask, but if I asked for CA, CA would be 12. Now, nothing changes if I add variables in. So here, VI is a median. It's part of the given. So XW is 3x minus 4, and I to w, this piece right here, is x plus 1. Since this is a median, I know these pieces are equal, so this piece is also x plus 1. Find x. So all I need to do is write an equation. Again, parts to whole. Two of those, you can either write x plus 1 plus x plus 1, the two little parts, equal the whole, or you can say, well, they're both the same, and so I'm going to do it this way. They're both the same, they will get you where you need to go. So I'm going to do the distributive property. 2x plus 2 is equal to 3x minus 4. Subtract 2x from both sides. Add 4 to both sides, and x is 6. Again, you can substitute it in. That means this is 7. This is 7. 3 times 6 minus 4. This better be 14. 18 minus 4 is 14. And so everything checks. Now, just for review, let's make sure we remember an angle bisector. Again, here, you know equal angles. If I give you angle bisector, you know nothing here. So it's really important that you study your vocabulary words so you know exactly what we mean. Now we have another important segment, and it's called a perpendicular bisector. So perpendicular means our 90 degrees. Bisector cuts in half. Now at its purest form, here it is, a segment that is perpendicular and cuts in half. It may be also the special case, which we'll talk about more later, when that point here is on the perpendicular bisector, some really cool things start to happen. But at minimum, this is the minimum definition. A segment perpendicular to a side and intersecting at the midpoint. So you get two pieces of information. You get perpendicular and equal segments. And then in this special case, you'll get more information. So let's quick do a review in this video. So in this case, I only know perpendicular. That means this is an altitude. In this case, I know perpendicular and bisected. It's not at a vertex. This is a perpendicular bisector. Here, my given information is that the segments are equal, and so that this is a median. And the last one, what information? This is cutting the angle. This is an angle bisector. So try the practice problems and tune in for the next video.